Let's start the session today. So today we'll start with a new module and that is threads. So we'll go over the topic multi-threading. So what exactly is multi-threading and why is multi-threading required? Let's first think over it. So multi-threading in Java is basically like accessing or executing different parts of a program simultaneously. So at the same time, suppose you have a program, so you want to access different parts or execute different parts of that particular program concurrently or at the same time. This is for uh, like uh, utilizing the maximum CPU or like every system has a CPU and memory, right? So we want to utilize the processing power of a system as much as possible. So that is why what we do is we want the parts of a program to be executed concurrently or simultaneously. So that is the motto of multi-threading. And how do we basically achieve this? We achieve this with the help of threads. So now the question comes, what basically is thread? So let's say we divide a program into several steps of execution. Let's say we have a program and it has basically uh, 10 methods, and each method is a step of execution. Let's say we have different threads which are like executing each different method of the program. So we want to basically utilize the power of multi-threading or the processing power of the system. So w- these threads are basically uh, a, you can say it's a kind of a lightweight process within a process. So let's say we have a program, so executing that program is a process. Let's consider executing a program is a process, and we have like several small processes within that. So those small processes or small steps of execution of that particular program, that is basically called threads. So we can say in Java terminology, like threads are basically lightweight processes or like simple and short processes within a process. So if there are like multiple threads, so we can utilize the processing power of a system, and that basically helps in improving the performance of the program. So we'll go over this module and we'll cover these particular topics like introduction to multi-threading. So that's what I was like giving as of now, and then we'll see what are the different ways in which threads can be like created and executed. So we have like different methods like using interfaces and using thread classes. So we'll go over those things like how we can basically create and execute threads. And then we have like different thread life cycles. So life cycle is basically how a thread comes into picture, how a thread is like created, and what are the different steps it performs in the processing, and how a thread is basically terminated. So this is the life cycle. So we'll go over the life cycle, and within the life cycle the thread has basically different steps, or we can say like the thread has different states like creation state, processing state. So there are different names attached to that. So we'll see what are the different states of threads as well. And then we have a different scheduling and priorities. So suppose we have a situation in our program that we want to perform some kind of scheduling, or we want to prioritize one of the threads execution. Let's say we have 10 threads in the program which are like executing simultaneously, and we want to prioritize one of the threads to execute prior to the other thread. So we have different mechanism for that in Java. So we'll go over this topic as well, like thread scheduling and priorities. Then comes thread synchronization. So why is basically synchronization needed? So this synchronization is a very important topic in multi-threading, and it is basically like, suppose uh, you have a read and write kind of scenario. Suppose, let's take the example of a bank. In bank, basically you perform two types of transactions, right? Either you deposit the money or you withdraw the money. So let's say you have deposited some amount. Let's say you have your ATM card or the debit card, and someone within your family went ahead and like deposited some money in your account, and you are trying to withdraw the amount at the same time. So what happens? Like, suppose someone deposited certain amount in the uh, bank account, in your bank account, and at the same time you are trying to withdraw, and you might not see at the same time, like, means let's say at this particular moment both the actions happened, like depositing money as well and withdrawing money as well. So if there is no synchronization, then what will happen? So the amount that is deposited in your account is not reflected while you are withdrawing the money. So either one of them will happen first, so the synchronization will not happen. So there is a mechanism how synchronization can happen, such that you do not run out of balance. So it's that process is basically called thread synchronization. Like, if a certain process is happening, there is some millisecond of execution time for that particular thread, and we will ask other thread to wait for some time. So we'll see how this can be like achieved using thread synchronization. This is a very important topic, thread synchronization. And then we have like another topic like inter-thread communication. So inter-thread communication is basically like, let's say within a program execution we have a number of threads. Let's say we have 10 threads. So if we want that one of the threads is executing the program, as of now it is like executing one of the steps, and let's say the other thread is also trying to execute the same step. So that can happen, means threads can try to execute the same step of a program. So we would not want that, right? Because one of the threads is already like processing that particular step. So in that case, what we will do, we'll communicate with the other thread that, can you please wait for some time? Let me try to finish this particular step and then you can start. So that kind of communication is called inter-thread communication. And once that particular thread completes that particular process, then it lets or notifies the other thread that I am done. Can you please come and go ahead and try to execute this step? So the other thread can come and try to execute that particular step. So that this entire process is called inter-thread communication. We'll see how we can basically achieve this inter-thread communication. And then we have one problem like deadlock. Let's say, what is basically a deadlock? So deadlock is a kind of a situation like you are waiting for one of the threads and that particular thread is also waiting on you. So let's say, like, there are two conditions and neither of the conditions gets completed because both the threads are like both the conditions are like dependent on one another. So let's say we have some condition 1 and condition 2. For condition 1 to be executed, condition 2 needs to be executed first, and for condition 2 to be executed, condition 1 needs to be executed first. So this is kind of a scenario which can never be completed, because each of the conditions is dependent on each other. So such a scenario creates a deadlock kind of situation. So why, how basically a deadlock is created, and what is the mechanism to uh, remove the deadlock. So we'll go over these concepts as well. Then there is some kind of APIs available with thread or multi-threading. So those are concurrency API. So concurrency API basically helps you to achieve parallelism. Parallelism means it will allow, it's kind of a Java library that helps you achieve the concept of multi-threading. Means executing different parts of a program using different lightweight steps and or threads. So we have some kind of like inbuilt Java API or library that is available, and that is basically called concurrency API. And concurrency API is basically one of the important libraries that helps you, like it simplifies basically your thread creation and thread execution of different parts of a program. So that is basically the role of concurrency API. So these are some of the topics we'll go over each one by one. So what is basically multi-threading? Multi-threading is executing multiple programs simultaneously, and series of steps executed at a time is known as a thread. Series of steps executed at a time is called thread. See, let's say we have some methods created. Let's say we have a bank account class, and in that bank account class, basically what are the methods that are defined? Those are like get balance, and let's say we have one of the deposit methods, and then we have set balance methods. So these are some of the steps in a program, and we want threads to perform simultaneous execution on this particular, on this kind of methods. So these can be like achieved with the help of threads. Let's say we have get balance, we have deposit method, and then we have some kind of set balance. So these are some of the methods that are there in your bank account class. So how will you maintain parallelism, or how will you maintain synchronization between these things? So these can be achieved with the help of threads, and there are several mechanisms like synchronization and communication that we'll see how that those things will basically help you to achieve multi-threading. So see, execution of such steps by different threads can be considered as multi-threading. Let's say we have two threads. Let's say we have two threads, thread A and thread B. So see, what you would basically uh, means when you basically run your program, you are running your Java program, right? So at that particular time, what you are doing, your Java program, you are trying to run over it, you're compiling and you are running that program. So at that particular time, what happens? A single thread will be basically running your Java program. So now what you want to do, let's say you have created some methods in your program. Let's say you have created some methods in your program, and you let's say you have get balance, deposit and set balance methods, and you want two different processes to execute all the methods. Means at the same time, two different processes will be basically executing your get balance, deposit and set balance methods, and one thread should not affect the other. Let's say one thread is basically getting the balance, depositing and setting the balance, and the other thread is also doing the same thing. So one thread, one the action of one of the threads should not affect the other thread. So that is basically achieved by synchronization of threads. So we'll go over that as well. But the action of one of the threads should not affect the other. Means, let's say one thread is trying to get the balance. Let's say we have some 1,000 rupees in the bank account, and thread A has already seen that 1,000 rupees are there in the bank account, and it tries to uh, withdraw that particular $1,000 from, or 1,000 rupees from the bank account. And at that same time, thread B already withdraws that particular amount. So what, and they both have access to the same bank account. Let's say this both have access to the same bank account. So what happens? Thread A has also seen $1,000 in the bank account. Thread B has also seen $1,000 in the bank account. So let's say at the same time, if they try to withdraw the same amount, so only one of them can be only one of them can get that particular balance, right? Only one of them will be able to withdraw that balance, and by the time one of them withdraws that particular amount, the balance will already be zero, right? So how that is basically reflected to the other thread, means it cannot be like both of them can withdraw 1,000 rupees at the same time, because altogether you have just 1,000 rupees or $1,000 in your bank account. So if one of them withdraws, the balance goes to zero, right? So other thread should not be able to withdraw. So what are the mechanisms that we follow such that the other thread does not think, oh my god, I had 1,000 rupees, I'm not able to withdraw. So that particular thing, that current balance, how we can like stop one of the threads from affecting the other thread. So we'll see all these things. So these are basically achieved by thread synchronization. So there are like lot of concepts in threads, and means there is APIs, and there are different ways of achieving that, but there are like lot of concepts. We'll go over each of them one by one. So this is that example only, like get balance, deposit, and set balance. And there are two threads, thread A and thread B, which will be trying to perform all these operations. So let's say thread A has performed some operation. So at that time, how thread B can be asked to wait for some time. And once thread A has done, let's say that particular thing is like updated, and thread B can now start performing like fetching the balance or depositing certain amount in the bank account. So these are some of the steps involved in multi-threading. Let's go over another slide. Okay, so how we can basically create a thread. So let's say we want to create a thread in Java, and what is the mechanism of basically creating a thread. So we have seen the concept of classes and interfaces as of now, right? Means you are already familiar with the concepts of classes, you are already familiar with the concept of interfaces. So threads can be created by two ways basically. There are two fundamental ways in which threads can be created, and one way is basically like extending the thread class. So you are aware that at the top of hierarchy there is this object class, and from this object class this thread class is extending. At the top of the hierarchy there is object class, and then this thread class extends from the object class. Means you can say thread class is a child of the object class, and this thread class is basically in java.lang package. So we have seen one of the packages last class when we were going over collections, right? So all the collection data structures are available in java.util package. So where is this thread class available? This thread class is basically available in java.lang package. And that's why you can see this java.lang.thread class. So basically java.lang is your package, and .thread is basically your class. So when you want to create your own thread, when you want to create your custom thread, what you can do, you can create your own thread by extending this thread class. So you need to extend this thread class. This is like the concept of inheritance. You basically want to inherit the thread class, so that some of the methods which are available in that particular thread class, those will be available to your class, and your class can behave like a multi-threaded program. So for that purpose, you need to extend the thread class. And other way is basically creating the object of class which is implementing the runnable interface. So runnable interface also has the same method which this thread class has. So either way you can like create the threads, like you can implement the runnable interface or extend the thread class. You know that interfaces basically have prototype or like a signature of your methods. So that particular method is available in interface, runnable interface as well. And this is also in java.lang package. So if you basically create the object of the class which is implementing the runnable interface. So let's say you have one of the classes created and that implements that runnable interface. So you need to create the object of that class which is implementing the runnable interface. So we'll see, we'll go over the code and see like how basically you can create the threads. This is like an important interview question as well. So fundamentally they can ask like what are the basic methods through which threads can be created. So there are two ways. This one way is like you can extend the thread class, that is like inherit that thread class, or you can implement the runnable interface, and the class which is implementing the runnable interface, that has to like the object of that class has to be created. So we'll see the let's say we are trying to first create the achieve this thread concept using the thread class. Let's say we will extend this thread class first. We'll go over step first way to create the threads. Let me go to the IntelliJ editor and let me try to create a new package, and let's say we name this as multi-threading. And we are aware now that threads can be basically created by two ways. One way is by extending the thread class or inheriting the thread class, and the other way is to implement the interface. And which interface do we need to implement? That is runnable interface. Okay, we'll see the first way of creating the threads. And let's say we create one class and we name this class as my thread. And now we have discussed that we need to extend the thread class. So we'll use the concept of inheritance. And see, when I write thread, so the first option that I'm getting is thread java.lang. So once you like press enter, you will see an import. You will see an import that java.lang package is already imported, or means java.lang is the default package. So you will not see, you can do something like this, but this is the default package. If any other package is, if you need any other package, you can also do something like this, but this java.lang is one of the default packages in java. That is why if you see like, if you go over any other let's say we go over this collection framework, and you want to see some of the classes. So you will see that these import statements are there. Means whenever you create an array list or you create a list, basically you will be seeing these import statements. But anything in the java.lang package, whatever classes are there, even if you don't import this will work, because this is one of the default packages in Java. So that a feature Java has provided, even without importing java.lang package, the thread class will be inherited. But you need to write this extends thread. You need to write basically this extends thread. And let's say we will create one constructor. We'll create one constructor for this particular class, and in the constructor we will pass a name. And this will be basically the name of the thread. Let's say I want to provide some name to our thread, so we will pass this particular parameter to this constructor. And why we are passing this name to this constructor? In the thread class, if we go into the documentation of this thread class, let's go to this documentation of this thread class. So see this constructor. So basically this thread class has a constructor which needs this particular parameter like string name, and we want to pass this thread name from the class that I am creating. So I am creating a class my thread, and my thread is our custom class. In this class we want to achieve multi-threading, so that is why we basically inherited this thread class, and we want to provide some name to our thread. And we know that in the thread class we have a constructor which needs this string, which needs the string name. So this name is basically allocates, see the documentation, allocates a new thread object. This constructor has the same effect as thread. So if you pass a parameter, it will basically you know the concept of super, right? When we pass something with the help of super, so this particular statement will call your parent class. And which is your parent class now? It is your thread class. So whatever name you want to provide to your thread, you can pass it with the help of super. I'll again repeat, super, we have seen the usage of super while we were going through the concept of inheritance, and we had also seen the usage of super when we were going through the concept of method overriding. You remember, with the help of this super keyword, we were able to call the constructor of the parent class, and with the help of this super, we were also able to call the overridden method of the parent class. So that is why we are using this super. We are trying to pass this particular argument to the constructor of the parent class, and we have seen that there is a constructor in the parent class which basically takes the string, and that's why we have passed this name. So this is the creation of the constructor. In this constructor, this is the thread name, and we are passing this thread name to the parent constructor, parent class. Let's say passing thread name to the parent class thread. Now when we create a thread and we are extending the thread class, so basically we will need to create one method, and this method will basically will need to, let's say we are trying to uh, iterate over a loop of like 1 to 10. So there's a run method in the thread class. This run method is basically there in the thread class, and we are trying to like override it. And let's say in this run method we are trying to print from 1 to 10. So we'll use a for loop, and I is equal to 0, I less than is equal to 10. Let's say we want to print from 1 to 10, and I plus plus. And what I will do, let's say I'm printing this I, and let's say what I'm trying to do is I'll provide some run by. We'll try to get the name of the thread. We'll try to get the name of the thread. So there is a method called getName. We'll try to get the name of the thread. And let's say we go ahead and create one main method, and you need to basically create the object of this particular class. And let's say you name it as like my thread t1 is equal to new my thread. And see, if you don't pass any parameter, you are getting an error, right? So why you are getting an error? Because you have created a parameterized constructor which requires a string name. So let's pass this. Let's pass some name to this thread. Let's name this as thread1, and let's create another object, my thread t2 is equal to new my thread. Let's pass some name here. Let's call it like thread2. And see, what are the things we have which we have done. One thing is like step 1 is basically extend thread class. Now step 2 is create a constructor and pass thread name to parent class. And then what we are basically doing, third step is implement the run method. Implement run method. And fourth is basically creating the threads, creating the object of the class, creating the object of the class extending thread. And fifth step is basically starting the thread. So we need to start the thread as well. Start the threads. So there is a start method in the thread. So let's say we start the thread, the first thread, and then we start the second thread. So let's try to run this program. Let's see the behavior of this program. Okay, let's provide some space here. See what kind of output you're getting. So this is like the output of your multi-threaded program. Whenever you did not write this run method, right? In a usual program, when you just in a normal program, when you run a for loop from 1 to 10, what you will get the output? You will just get like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But see this program here. What is happening? Like you are getting this printed, like one is getting printed and run by. Which thread is basically running this method? Which thread is basically like executing this particular method? It is being executed by thread 1. It is being executed by thread 1. So this is decided by the processor, or like this is basically decided by the thread scheduler. We have a concept of thread scheduler. So thread scheduler can ask any of the threads to run this particular step. So see, now you're getting an output of 1 run by thread 1. Then you're printing 2 again run by thread 1. So this get name method is basically giving you the name of the thread. This get name method is basically giving you the name of the thread. And what name it is giving? It is giving the name thread 1. So while creating the object of this thread class, we are passing a name, right? This name is basically passed to this particular constructor, and this particular constructor passes it to the parent class, and the parent class is your thread class. So now your thread is created with a name of thread 1, and similarly the other thread is created which is thread 2. So what we basically do now is we are trying to implement this run method. So whenever you extend your thread class or you implement the runnable interface, you definitely have to provide a definition in this run method. You will always override this run method, and you will write whatever logic you need to write in this particular run method. So I am trying to run a loop, and I'm trying to print from 1 to 10, and I'm trying to print the value of I, and I'm trying to print like this is like uh, which thread is basically printing this. So there's a get name method, and this get name method will be able to this will allow us to print like which thread is basically printing this. So see, the order of output is different this time. Like 1 run by thread 1, 2 run by thread 1, and all of a sudden you can see here 1 run by thread 2, 2 run by thread 2, 3 run by thread 2, 4 run by thread 2, and so on. So both the threads are trying to run this. So this is like the concept of threads. This time when you try to run, right, see, Now you see the output. There is some difference, right? Initially, first time when you ran, it was one run by thread 1. Now thread 2 is able to run this, and you cannot keep control over this. There is like the thread scheduler. There is a concept of thread scheduler in Java, and that thread scheduler basically decides which thread will be executing this run method. So which thread will be executing this run method, that is decided by the thread scheduler, and that is why thread 2 is running the program. Thread 2 is basically running your run method now, and then thread 1 is running your run method. So see the difference. You don't have control over this. Thread scheduler decides. Now see this time. See the uh, type of output, like 1 run by thread 1, and until 9 you are seeing 9 run by thread 1, and then what happens, this thread scheduler decides like 1 run by thread 2. In between, like, the other thread came and tried to run this method, and after that 10 run by thread 1. So see, there is some kind of like synchronization broken, right? So we now there are two threads, but there is no communication happening between the two threads, and both the threads are like running simultaneously. There is no synchronization or intercommunication between these two threads. So both these threads are running simultaneously and they are providing you random output. So we will see in further classes like how you can basically provide some kind of communication to the threads, and how you can control the behavior of threads. Let's say we want only the first thread to run for now, and then the other thread should run. Let's say first thread completes like printing everything, and then only the second thread comes into picture, and then it prints that thing. So that is the process of synchronization and thread communication, which we will see when we go over that topic. But this is a simple program how to create a thread. Basically there are like 5 steps you will do. The first way is that you can extend the thread class such that you are inheriting the thread class properties. Next, you need to create a constructor and pass the thread name. You are taking a parameterized constructor and you are basically passing it to the parent class. Your parent class is basically the thread class, and you are using the super keyword. You have already seen the usage of super keyword in the module inheritance and polymorphism, right? In method overriding and inheritance, you have seen the usage of super. So next is you will have to implement the run method, and whatever logic you want to write, you can basically write in this particular for loop. And this get name method is basically your it is trying to get the name of your thread. So you have provided the name of your thread when you created the object of the class. When you created the object of the class, you have passed a name to your thread. So this is like thread 1. So this get name will give you either thread 1 or thread 2, and finally you will start the threads. So there's a start method in the thread class that we need to call, like t1 dot start and t2 dot start. So this will basically help you to start running your threads. And once this t1 dot see, we are not calling the run method t1 dot run, but when you do this t1 dot start, right, it will implicitly call this run method. So this is the feature how this will run. When you do this t1 dot start, it will basically call your run method. So whatever logic you have written in the run method, basically that will be called. So that is why you are seeing this output. You in your main method, in the main method that I have created, I have not written like t1 dot run anywhere, right? But still, when we do this t1 dot start, that means that we are trying to start a thread. We are trying to start that particular thread, and when we start the thread, what happens? This particular run method is executed. So this is like one of the ways in which you can create a thread. So this is the first basic way in which you can create a thread. We'll see now the other way how you can create a thread. So we have discussed earlier, right, that you can also implement the runnable interface and then try to achieve the same. So let's go over that. Let's say I name this as my runnable. Let's say we name this class as my runnable, and in the previous class we had extended this thread class. Now we will implement this runnable interface. So let's say we want to implement the runnable interface. See, again this runnable interface is in the java.lang package. So as soon as I import, there will not be any import statements. If I had imported anything apart from java.lang package, you would see some kind of import statements here, right? But in this case you will not see. So see, as soon as you implement the runnable interface, you will get an error. So this will basically ask you to implement all the methods which are there in the runnable interface. When I click here, right, when I hover over this error, see my editor is giving me some error message, and it is asking me class my runnable must be either declared abstract or implement abstract method run. So this method run is basically in the runnable interface, and you know that in an interface all the methods are abstract. That means in an interface the methods only have the signature. You do not have the definition or the implementation in the interface. So whichever class implements that particular runnable interface, that class has to provide the implementation for that particular method. So once I click on this implement method, right, see this editor will automatically create that run method for me. It will automatically create the run method for me. Let me try to go over it and try to click this implement method. Everyone is able to see this implement method, right? So I'll click on this implement methods. See, it is asking whether you want to select this and click OK. So we'll click OK. And see, in the last class, sorry, in the last program, we had to go and write this run method. But here, when you click on that implement methods in the editor, you automatically get this run method definition. Let's try to again uh, run the same loop, create the same loop which we have created here. I'm just copy pasting that. So let me try to, so here you will need to, so our thread class basically has a method like thread dot current thread dot get name. There are like a lot of methods, but I will just print the name of the thread now. So how we can basically print the name of the thread? This is one way to print the name of the thread, like thread dot current thread dot get name. So sometimes you won't get that import here, like the static import. So what you can do, thread dot current thread. So when you write this thread dot current thread, that means that whichever thread is currently running, currently executing this run method, that thread's name I want to print. So you can do something like this, thread dot current thread dot get name, and this is the same logic that we had written in the previous program when we were writing the my thread class. We wanted to print from 1 to 10, and now I'm trying to print the same. So let me try to now go ahead and create this main method, and what we'll do, we'll try to create the object of this class. Let's say I want to create the object of this class. So I've created the object of this class, and now what you want to do is basically you want to create the object of the thread class, and let's say we name it as t1, and we create the object of the thread class. And when you create the object of the thread class, this has like different type of constructors. Like you can pass this runnable interface, sorry, the object reference here, and let's say we create another thread t2, and we can do something like this, empty, and we do like t1 dot start, and we do something like t2 dot start. And if you want to further provide names to these threads, right, if you want to further provide names to this thread, let's say we will provide some names to this thread. So what you can do, what you can basically do, you can go ahead and try to provide the name of this thread. Let's call this thread 1, and let's call this thread 2. So if you go in this thread class, right, basically you will see that there are different type of constructors. There are different type of constructors. So see this, what it is trying to get. This is taking your runnable target, and this is taking your string name. So that is exactly what I'm doing. So our class implements the runnable interface. So this is our runnable target, and you have the object reference of that particular runnable target. So you need to pass this, and then it expects a string name. So in this Java doc, you will read this. Let's read this. Allocates a new thread object. This constructor has the same effect as thread null target name. Okay. And what are the parameters that I need to pass? Target. Let's see, what do you mean by target? The object whose run method is invoked when this thread is started. So the object of whose run method is invoked. So which class has this run method? Which object will be which object we need to create? So this is our myRunnable class, and we have created the object of this myRunnable class, and this class has basically our run method, right? So you need to create an object of that particular class, and this particular object reference needs to be passed when you create the object of thread class. And you can you can pass this name. You can also choose to not pass this name, but we want to basically, we should pass the name such that we know like which thread is basically executing this. So I am passing this thread 1 and this thread 2, and then again this is like t1 dot start and t2 dot start. We are starting the threads. Let's try to run this program. See, we are again getting similar kind of output, right? We are again getting similar kind of output, like 1 run by thread 1, 2 run by thread 1, and then all of a sudden after like everything is printed by thread 1, we are getting 1 run by thread 2, 1 2 run by thread 2. This can, the order of this can also be changed. let's say, see, now you're getting 1 run by thread 2, 1 run by thread 1, 2 run by thread 2. So the order is like something random because there are two different threads and both the threads are trying to run the same run method, and that is why there is no synchronization or proper communication. We will see in further classes like how we can achieve this synchronization and uh, intercommunication between threads. But as of now, what I'm trying to demonstrate is the same output, means the same program is being run by two different threads. Means if like one was printed, there was no need of like other thread going ahead and printing again one, right? But I have like created two threads, and those threads are basically executing this program. So as of now, there are two different threads which are trying to execute some part of this program, and that part is basically your run method. So executing this run method is a step, like, and this is performed by two different threads. So you understand now, right? Like in our normal program, what we used to do, we used to simply, let's say I write down something like demo.java. So what we used to basically do, uh, let's say I want to print something like int equal to 1, I less than equal to 10, and I plus plus, and let's say I want to print this. Let's say I'm printing out I. Let me run this program. See, we are able to get this output only once. Why? Because there is only single thread here. We did not create any thread here, right? And there is only single thread which is trying to run this program. And that is why we are getting this output only once. But in this case, right, we are creating this run method, and then we are creating different threads. We are creating two threads. So whatever logic is being written in this particular method, in this particular run method, and in this loop, this will be executed twice, because this method is being called by two different threads, and that is why we are able to see the output twice. One time 1 2 3 4 5 6 7 8 9 10 is being run by thread 1, and the other time it is run by thread 2. And this order of output can vary because the thread scheduler decides which thread is now running this run method. So that is about it. So these are the two methods in which basically this uh, threads can be created. Let me know if you have any questions for now. Okay. Okay, we'll go over the slides.
Hi, Pritam.
Yes.
Yeah, can you go for the demos?
You want me to go to the editor? Yeah.
Yeah, from my thread. So my runnable, yes, I'm clear. But from my thread, can you go to my thread?
You want me to go to my thread, right? Okay.
Thread, yeah. So this is for we using for the like uh, extent of thread.
Yes.
Thread is a parent class, yes. My
Yes.
thread is the
Yes.
child.
Yes.
So where we create the thread,
So this thread class is basically your parent class, and your my thread is your own class. This is a user defined class that you have created. This thread class is already existing, means it is an inbuilt Java class which is basically extending from your object class, and this thread class has already some built-in constructors which receive some arguments. So this thread class has one of the constructors where means you create parameterized constructor, right? So this thread class already has a parameterized constructor which will be accepting a name, and that is why what I'm trying to do, I'm trying to pass this particular name of the thread from our constructor, this my thread constructor. And you know the process of passing, right? Means if you want to pass or some arguments to your parent constructor or call your parent constructor, you can use this super keyword. So I'm calling the parent constructor with the help of this super keyword, and I'm passing this string name. And next, either you create the threads by implementing the renewable interface, or you create it by extending the parent class thread. In both the cases, you will have to provide definition for this run method. And in this run method, I am simply just trying to print out 1 to 10. And what I'm trying to showcase here is this 1 to 10 will be printed by two different threads. So each time this print statement will be executed, like, see, if it was not, if this class was not implementing threads, so we would get just our output like 1 2 3 4 5 6 7 8 9 10, right? But there are like two threads, two different threads which will be executing this particular method, and this particular statement will be like printed 10 into 2 20 times, because there are two threads, 10 iterations and two threads. So 10 multiplied by 2, there will be 20 different output statements here. So this is basically the output you can see. Is it clear, guess? Who asked it? Guess or it?
Okay, yeah.
Yeah, okay. And then this was using the runnable interface. So as soon as you implement the runnable interface, you will have to provide definition to this run method. And here what we basically do, we create the object of the class, and then we pass this object reference to the thread class object. When we create the thread class of object, we can pass this object reference here, and we can pass some names to the this is basically the name of the thread that you want to pass. So this is the syntax. So if you go in this particular class documentation, you will get to see this is the runnable target. So runnable target is basically this object reference, and then it is asking for string name. This is basically the name, is basically the name of the thread. So I'm just giving something like thread 1 and thread 2, and then I'm starting both the threads. When you start the threads with t1 dot start or t2 dot start, so it will go ahead and try to execute this run method. So as soon as t1 dot start is done, the execution of this run method starts. So this is how you create the threads in two ways: extending the thread class and implementing the runnable interface. Okay, we'll go over the slides. So we had created the threads using extend inter by both the methods, by extending the class, thread class, and also by implementing the runnable interfaces. So let's go over this. This is like basically constructors in thread class. So we had already seen this thread, right, where we can pass the string name. Then there are some different constructors when you can pass like a runnable target. We have seen the fourth one also, right, where we had passed the runnable target, that was object reference, and the string name, whatever the name of the thread you want to keep. So these are some of the predefined constructors in the thread class which you can create and pass the uh, which you can like pass the name of the thread. Now see, there are few methods from java.lang.thread class. So in the thread class, right, there are these methods like current thread. So what current thread will basically do, it will get you the current thread means if there are like two threads, and now let's say I want to know like if my program is being executed by which thread. So if I do a current thread, then it will basically get me that particular current thread. Whichever thread is executing, that thread name you can get with the help of current thread. Now there is this set name. Set name is basically if you want to provide some names to the thread. So there is like thread dot set name. You can do something like thread dot set name as well, and then provide some name to that particular thread. So that is also possible. If you don't want to basically create the constructor and provide the name of the thread, you can do something like thread dot set name as well. So you'll get to write the name of the particular thread. You can pass the name of the thread that you want to keep. Then there is like similar get name. We have already seen the name of get name. We had already seen the usage of get name, which was able to print the thread which was executing the run method. Then there is this is alive method. Is alive method is basically telling you if your thread is already alive, means if your thread is not terminated as of now, means there are ways in which you can terminate the threads, right? So this is alive method will be basically telling you if your thread is still alive or it is like already terminated. So there is this boolean method. So this will always return you true or false. So if it returns you true, that means your thread is alive. Otherwise, if it returns you false, that means your thread is already terminated or dead. Then there is this get id and get state. So get state will basically get id will give you the id of the thread. We'll see that when we write further code of thread. And then there is like get state. So there are like different states in a life cycle of threads. So this will basically give you the state of that particular thread. If it is in a runnable state, if it is in a running state, if it is in a new state. So this will basically give you the state of the thread. So see, this is the life cycle of a thread. So these are the different states. So when we create a thread, right? When we create a thread, so basically it's a initially it's in a new state, and after that what happens? It goes to runnable state. So any code that is basically executed, for any code to be executed, right, first that thread has to be in a runnable state, and from runnable state you can go to the running state, and from the running state you can go to wait and sleep. So let me try to explain this diagram. So sometimes you might be asked like what is the life cycle of a thread, and try to explain that particular life cycle. So let's say we are creating a new thread. So at that particular time that thread is in the new state, but that thread has not started to run any part of the program yet. That thread is just created, but it has not started to run anything as of now. And when the thread is in the new state, that code is yet to be run, and it is not executing as of now. Means the thread is created and nothing is running as of now by that particular thread. So that is the new thread. Then after this new thread, right, a thread goes into the runnable state. So what is basically this runnable state? So these are some of the terminologies basically you should be aware of when you read the concept of multi-threading and threads. So what is runnable state? So a thread that is ready to run means if your thread is basically ready to run, then it is moved to this runnable state. And in this state, the thread might actually be running or might be ready to run at any point of time. Means if your thread is in the runnable state, then that particular thread can perform some task. It can execute some code. So for that particular thing, the thread has to be in runnable state. And once the thread is in runnable state, the thread scheduler, whatever thread scheduler is there, that will ask one of the threads to start executing some part of the program. So for any thread to start executing any piece of the program, that has to be definitely be in the runnable state. And from runnable state you can go to the running state. So running state is basically currently that thread is executing some part of the code. So this is the sequence. First, new state means thread is created. Runnable state means that thread is basically ready to run, and it is now just trying to get started and trying to get execute some piece of the code. And when it goes to running state, that means that now it is already executing some piece of the code. So from this running state, what we can do, we can like either terminate the thread, we can either terminate the thread, either the thread can like terminate normally, or what we can do, we can like explicitly terminate the thread as well. So there are ways of like terminating the thread. So from this running state we can like terminate the state, or what we can do, we can ask the thread to wait and sleep. You see these arrows, right? Wait and sleep. From this running state we can go to three states. Either we can like ask the thread to wait for some time and then execute, or we'll ask the thread to sleep. So these are both like wait and sleep are different ways of like pausing the threads for some time. If you want to pause the thread for some particular time, then you can ask the particular thread to wait and sleep, to wait or sleep. So these are the different ways in which the thread can go in a waiting state. And once the thread is in a waiting state, it can be again resume to work. So if that thread is in a waiting state, now that you want again that thread to be in the runnable state, what you want to do, you want to again call that particular thread to runnable state, and then it can again start executing some code. So understood this life cycle. First thing is a thread is created. So at that particular time, it's in a new state. Now, next is from the new state, it goes to the runnable state. So runnable state, whenever a thread is in the runnable state, that means it is ready to run some piece of the code. And from that state, it can go to the running state. That means it is executing some piece of the code. And from that state, it can, that thread can be paused, that you want that particular thread to pause for some time and then resume some work. And once you want to resume that particular thread to perform some task, you have to call again, you need to bring that thread again to the runnable state, and from the runnable state again it will go to the running state. And from the running state you also have an option to terminate the thread, and that is basically called dead state. So that is basically called the dead state. Okay, TJ is asking one question like, what is the benefit of knowing thread as a developer? So TJ, one thing is like the interviewers will definitely ask you they can ask you some questions. One thing is the interviewers can ask you some questions related to threads. Other thing is when you write some real world programs, right? There one API can be accessed simultaneously. We will create some APIs when we create some Spring Boot projects. So there you will create some APIs. So that API in real world can be accessed by a lot of people, right? So we do not want that, let's say five people are trying to access the same API. So one of the person's actions does not affect the other person's action, right? So if one person has like accessed that particular API and has performed some task. So that should not affect other person calling the same API or the same piece of code. So that is why this concept of multi-threading is required, and multi-threading also improves the performance of a program. So otherwise what will happen if you don't have a multi-threaded system and a lot of the people are trying to access the API, your system will go into a failure state. At that time, your system will go into a failure state. Means you do not have that many threads in your program, in your environment. You do not have that many threads that can process the request of so many people. So for that you need threads, and we'll see like how thread pools and all those things are created in future, maybe in Spring Boot project. But this is the reason why threads are important. Means concurrent access of your API is done by a lot of people, and for that we need to make sure that one person's action does not affect the other person's action, and for that purpose we will need the concept of multi-threading. Is that clear, TJ? Okay, so we'll stop the class here itself, and we'll resume this multi-threading concept on Friday 9:30 p.m. EST, and it will be like Saturday 8 a.m. for the IST folks. So if you still have any questions, you can ask, or we'll conclude the call today.